Hello, we are on 8.2 day 2 and vectors in the coordinate plane. Today we're going to write a vector as a linear combination of unit vectors. We're also going to solve some problems using right angle trig. I said this part was a little bit more difficult, and I don't think it's difficult. I think it's just keeping everything from being confusing, because there's so much new stuff being thrown at you, and mostly it's new terminology. The actual math involved is really not that difficult. So I guess if you're an organized person, you'll probably be fine. So a vector that has a magnitude of 1 is a unit vector. And it's sometimes useful to describe a non-zero vector v as a scalar multiple of a unit vector u with the same direction as v. That was supposed to be italicized and darkened, whatever. So to find u, divide v by its magnitude. So this might be a whole bunch of mumble jumble, but it's the same thing as like a unit price. Okay, you go shopping and you have so many ounces of cereal for X amount of dollars, and you can find the unit price so that you know how many cents per ounce you're paying. It's kind of the same usefulness, just to relate it to something. So they kind of give us two formulas, which of course are the same thing. You take your vector and you divide it by the magnitude of your vector, and that's how you get your unit vector. This is probably kind of a nicer way for us to do it, where we just think 1 over the magnitude of the vector times the vector, just because it's scalar multiplication. Obviously, these are the same thing, not too worried about it. Let's get trying some of these. So it says find a unit vector with the same direction as v for -2. So what we first need to do is find the magnitude of this. So the magnitude of 4 squared is -2 squared. So we have 16 plus 4. So the magnitude looks like the square root of 20 or 2 square roots of 5. Okay. So now I'm going to set it up. So this is my magnitude of v. I'm going to do 1 over 2 square roots of 5, and I'm going to multiply it, and it's just scalar multiplication, times 4 -2. I'll wait to simplify this because I know I can't have a radical in the denominator, but I'll wait till after I get this done. So I'm just going to multiply this, so I get 4 over 2 square roots of 5, and -2 over 2 square roots of 5. Let me spend some time simplifying that. So this is going to be 2 over the square root of 5, but I need to rationalize the denominator. So I'm actually ending up with 2 square roots of 5 over 5 for my first value, my horizontal component. And then I will do the same thing here. So I end up with negative square root of 5 over 5. And that's my unit vector. Do another one real quick. I'll find the magnitude of this, so it's the square root of 25 plus 9, just your 5 squared and -3 squared, so the square root of 34. Doesn't look like I can reduce that all, so I'm going to take 1 over the square root of 34 and multiply it by my vector v. I'm just getting so tired of the same colors over and over. Let's do purple. Okay. So I have, I thought I said purple. There we go. 5 over the square root of 34, which we know we can change to 5 square roots of 34 over 34. And then -3 over the square root of 34, which is negative 3 square roots of 34 over 34. Okay, we will do linear combination, and this is really straightforward. We're just going to find the component form of vectors and then write it in this I and J, this linear combination. Nothing crazy new, just new stuff. So these, I'll read this. The unit vectors in the direction of the positive x-axis and positive y-axis are denoted by vector I, which is 1, 0, and vector j, which is 0, 1, respectively. That's basically saying that I is your horizontal and j is your vertical. Okay? So vectors I and j are called standard unit vectors. So we're going to just put them together. So it looks like this, and we'll put in our component form, we'll put in our A and we'll put in our B. So we'll put in our horizontal and we'll put in our vertical. It's nothing crazy at all. No rocket science involved, I promise. So let's find the component form of DE. So that was just 2 minus a negative 3 and 6 minus a negative 3. And now I'm going to write it as a linear combination of the vectors I and j, and I will write it like this. 5i, and that's a vector, I guess if I could darken it, whatever, plus 9 vector j. That's my answer. Ta-da! We'll do another one because it's so much fun. Let's do the component form, negative 1 minus a negative 4, so 3, and 5 minus 3 is 2. So my answer is going to be 5 vector I. Why did I do 5? That was kind of silly. 3 vector I think I was looking up here, plus 2 vector j. My i's and j's are so wonky. Okay, let's go to probably the hardest part about the whole lesson. We're going to talk about component form and direction angles. So this one, I'm going to draw these out. Whether you need to or not, that's kind of up to you. I like to, so I can kind of tell what direction everything is going, so I know when to put in a negative and when to put in a positive. And you'll see what I mean, I think, when we do this second problem on here. But it says find the component form of the vector v with magnitude 7 and direction angle 60. Well, I'm just going to kind of sketch that out. So we'll pretend this is 60 degrees right here. And then this has 7 is my length. And that is a great right triangle. Okay, you get the picture. So all I need to do is find this vertical and this horizontal. So I have my component form. So we got adjacent over hypotenuse. So I have cosine of 60 equals x over 7. And then I have opposite over hypotenuse. So I have sine of 60 equals y over 7. Now, you have these somewhere, and I guess I didn't dig them back up for you, but they are in notes, or I'm sure you can Google search them. But your common trig, you have cosine of 60, and that equals 1/2, and your sine of 60 equals square root of 3 over 2. And this is also just kind of your 30, 60, 90 triangle and whatnot. So what I can do then is, I don't even have to use my calculator, but you're more than welcome to, of course, is I can take 7 times 1/2 and get my 7/2. And I can take my 7 times the square root of 3 over 2 and get 7 square roots of 3 over 2. Then I have exact answers, and I'm not dealing with decimals for this guy here. But if you do decimals, I guess I don't really care. I just want you to understand how to do it mostly. In real life, when we tend to use decimals to round things, so not a biggie. Let's look at the next one here. And it says, find the component form of the vector v with magnitude 12 and direction angle 300 degrees. Well, 300 degrees means it's going to be, right around here. Whoops. Something like that. So if this is 300, that means this part right here is 60. And that's, I guess, what I was getting at. Wow, my lines are great today. Yep. Okay, I paused it and tried to put straighter lines and it still didn't work that well. But I have my right angle here, my 60 degrees here, and the magnitude is 12 right here. And again, we're going to find our vertical and our horizontal. So we'll do this again. We will do cosine for adjacent over hypotenuse. So cosine 60 equals x over 12. And remember, this is 1/2, so really this just equals 6. And then I'm going to have sine of 60 equals y over 12. And this is square root of 3 over 2. So square root of 3 over 2. I'm going to multiply it by 12, and I get 6 square roots of 3. One last thing I need to double check is my direction. This is in the 4th quadrant. So that means my x is positive, but my y is negative because it's going down. So I need to input my little negative sign right there. We'll move on to direction angles of vectors here. So we're going to do very similar to what we just did, except now we're finding the angle. So we have the component form, so we'll kind of draw that out, and then we'll just use, we'll use inverse tangent to find the direction angle. So I've got 2 this way and 9 this way. So that means I have a hypotenuse here, which I don't have to figure out. I really just need to figure out my theta, or my degree right there. So I have opposite over adjacent, which we know is tangent. So tangent of theta equals 9 over 2. So to find the actual angle, remember you need to use inverse tangent. So inverse tangent of 9 over 2. And I guess I would put that in my calculator. It says to round to the nearest tenth of a degree, so I get 77.5 degrees. Another one, this time they have it in linear combination form, but remember it's the same thing. This is just my direction of x and this is just my direction of y. So I have -7 vector I plus 2 vector j. So I'm going to go -7 here and +2 here. It's totally a right angle. Okay, 7 there. And I need to find this angle right here. Okay. So again, I'm going to have opposite over adjacent. So I will have my tangent. So if I do inverse tangent, oh my goodness, it's time for me to quit, of 2 over 7, because opposite over adjacent of my angle, that's going to give me theta. When I put it in my calculator, I get, I believe it's 15.9 degrees. But I need you to be careful here because that's this degree right here. But that doesn't give me the entire direction. So what I have to do is figure out what this angle is, which is pretty simple, right? 180 minus this 15.9 degrees, and I get 164.1 degrees as my theta, my final answer. So that is it for day 2. I hope you guys have a great week. Let me know as you have questions.